Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. I always look forward to spending Wednesday nights with you, hanging out, doing some math problems. So welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just absolutely love what we get to do, which is help you feel more confident and competent in your math skills as you are prepping for your upcoming exam, regardless of what that exam is. So we specifically focus on math here on Wednesdays. We do have a slew of boot camps available for all sorts of subjects, but we do focus on math on Wednesdays. So a couple of housekeeping notes. I am going to go through problems that range from kindergarten through 12th grade. And so if I'm doing a problem that doesn't seem to apply to you, fear not, don't worry, don't leave, because I do a variety of problems. And number two, I always like to cater what I am doing to help you. So I always have like a next week section. So if there is something that you want to see me go over in the upcoming weeks, please comment and let me know. It helps me build out the problem sets for the upcoming weeks when I know what you need. And so let me know in the comment box what you want to see me go over in the upcoming weeks. Hey, Leah, I am so excited to see you tonight. I always love like when people comment because it makes it feel a little less like a computer screen. So hello, Leah. It is good to see you. Hey, Hope. Two of my favorite people, two of my favorite Math Wednesday people. It is good to see you too. Let me know in the comment box where you're from, what test are you prepping for, and get to know you question. Where are you from? What test are you prepping for? And what is your favorite candy? With Halloween coming up and all the candy being around, what is your favorite candy? I am a chocolate girl all the way. Like, do not give me Skittles or Sour Patch Kids or Starburst or anything like that. Give me all of the Reese's, Three Musketeers. I am a dark chocolate lover, not a milk. I mean, I'll eat milk chocolate. I don't discriminate against chocolate, but I definitely like dark chocolate better. So give me all of that. I'm not a huge fan of like Twix or Crunch or anything like that. But I do love a good Three Musketeers, Snickers, Milky Way, that kind of stuff. So where are you from? What test are you prepping for? And what candy do you love? I actually keep the sour, fruity kind of candy in my office so that I don't eat it because I won't touch that kind of stuff. If I keep chocolate in my office, it is gone in like 2 days. Hello, Valeria. It is good to see you again. You're from Texas. Sour candies and chocolate. Leah, my little one, is obsessed with candy corn. And the only reason we found out is because he like will come up to me and be like, I'm listening, candy corn, please. And I guess his teacher, like, when they do a good job, they get candy corn for this month and they'll get something else next month and all of that. And so I was like, that's adorable. So he is a candy corn kid all the way. Fun fact, did you guys know that that it's called candy corn because when you stack the candy corn in a circle, it literally looks like corn on the cob? Who knew? I never knew that. So that is mind-blowing. All right, let's go ahead and get started with the first problem. Hello, Sarah. You are my kind of girl, a chocolate girl. I love it. All right, let's go ahead and get started with the first problem. We could sit here and chat all day. Let's be honest. All right, which of the following right triangles has a hypotenuse with a length that is an irrational number? A right triangle with leg lengths of 5 and 12, a right triangle with leg lengths of 8 and 15, a right triangle with leg lengths of 7 and 21, or a right triangle with leg lengths of 40 and 9. Which of the following right triangles has a hypotenuse that is with a length that is an irrational number? All right, so when we look at this, hey Tanya, it is good to see you. You like sour candies and chocolate. You people who like sour candy and chocolate, you're an anomaly to me. All right, so when we think about a right triangle, there's our right triangle. We know that we can use the Pythagorean theorem to figure out an like the legs and the hypotenuse. So let's remember that the Pythagorean theorem says a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. So with that said, if A and B are the legs and C is the hypotenuse, then I know that if I'm looking for which of the following right triangles has a hypotenuse with a length that is I thought that said a leg, with a length that is an irrational number, I'm looking for the C value to be irrational. So I also need to know what an irrational number is. An irrational number is a number that is not rational, which means it's a number that's like not pretty, not divisible, not like pi, or like, I'm trying to think of another one, like a number that's a non-repeating decimal. So when we look at this, what we can do is we can use the Pythagorean theorem by doing a squared plus b squared equals c squared. And whatever this plus this squared is has to be a number that is not a square root. Let me show you. So if I do 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144, which equals 169 equals c squared. Can I take the square root of 169? Yes, I can. And because of that, that is a rational number. It is not irrational. I can take the square root of that, which means it's a pretty number, like I like to think of. So A is not the right answer. So let's move on to B. 8 squared plus 15 squared equals c squared. 64 plus 225 equals c squared. $64 plus 225 is $289. And then if I do the square root of 289, that is 17. So C equals 17, which means that is not the correct answer either. Are you following me? So now we're going to do C, 7 and 21. 7 squared plus 21 squared equals C squared. 49 plus 441, and yes, I am using my calculator for some of this math. 441 plus 49 equals 490 equals c squared, and the square root of 490 is 22.135944. That right there is our answer, because that is not a rational number. That is a repeating decimal. That is not a rational number, or that's a non-repeating decimal, and so it's not a rational number. Does that make sense? So this is the kind of problem. If you have to know what Pythagorean theorem is, this is kind of one of those problems where they would have you do the application piece of it. So this is that application piece of Pythagorean theorem where they're not just saying, hey, what's the missing side? This is 5, this is 12. What's the missing side? They're saying, hey, which of these pairs is an irrational number? And you have to know how to apply that Pythagorean theorem. Yes, A and B are Pythagorean triplets. I choose not to memorize something like that just because I can solve for it. I don't personally like to memorize stuff that I can solve for because it just takes up unnecessary space in my brain. However, some people prefer the memorization method. Yes, the key word was irrational number for that hypotenuse. All of that processing is correct, Leah. All right, let's go ahead and move on to problem number 2. Triangle P has base and height dimensions B and H respectively. Triangle R has dimensions B minus 4 and H plus 4, where B must be greater than 4 and H must be greater than 0. Which of the following must be true? A, the area of triangle P is less than the area of triangle R. B, the area of triangle P is greater than the area of triangle R. C, the perimeter of triangle P is less than the area of triangle R, or that should say perimeter. The perimeter of triangle P is less than the perimeter of triangle R, or the perimeter of triangle P is greater than the perimeter of triangle R. All right. So when we're looking at this problem, this is one of those problems where I feel like our brains might go, oh no, I have no idea how to solve that. That's a whole lot of words. Where do I even go from here? And for those of you wondering, somebody specifically asked for Math 115 Competency 1. And these two problems are like absolutely Math 115 Competency 1. This is really like a 3rd through 12th grade problem, it really could be that. All right, so triangle P, it doesn't matter what triangle P looks like. It doesn't matter what triangle R looks like, okay? We're just going to call this P and this R. And it says has a base and a height. So this is the base of triangle P and the height. And this is B minus 4, and this is H plus 4. Because it says that they take the B and they subtract 4 to get the R base, and they take the H and they add 4 to get the base. Which of the following must be true? So I can sit here and use the letters to kind of figure out what we're looking at. So the perimeter of triangle P and the perimeter of triangle R versus the area of triangle P and the area of triangle R are going to be two different things. However, we don't really know the perimeter of either triangle. They didn't give us enough information to be able to figure out the perimeter of each triangle. We have no idea what relationship this leg has or this leg has in relation to the rest of the triangle. So we really can't talk about C and D. So now when we look at area, what we can do is we can do the area formula for P and we can do the area formula for R using these variables and see what we get. So the area formula for P is 1/2 base times height because that's the area formula for a triangle, which equals 1/2 base times height because my variables are a B and an H. So we could do BH divided by 2. Now, the area formula for triangle R is going to be the same, but it's going to be 1/2 B minus 4 times H plus 4. Interesting, huh? So in this case, if I were to distribute, I would get 1/2 times B times H plus 4B minus 4H minus 16. And that really isn't all that helpful. It's just longer. So here's what I like to do in these situations. I like to make up numbers and kind of play with the situation. So I'm going to do a test. I'm going to do a test 1 and I'm going to do a test 2. And I'm going to see what happens if I pick arbitrary numbers for my base and my height. So if I have P's base is, 12, and the height is 9. Then that means 1/2 base times height, 1/2 12 times 9 is 54. And R, if P has a base of 12 and a height of 9, then R is going to have a base of 8 and a height of 13. How did I get that? I did base minus 4 and I did height plus 4. So 13 times 8 divided by 2 is 52. The area of P is greater than the area of R. Now, if I was actually solving this problem, I would stop there and move on, but I would flag this problem. Here's why. Because what I did was literally pull numbers out of thin air and test it. And what I don't want to happen is that my one test is just happened to be like a lucky guess. And so I don't want to spend 12 minutes on this problem. This problem's not worth 12 minutes of my time. In fact, no problem on any math test should be worth 12 minutes of your life. However, what I am going to do is I'm pretty confident that's my answer. I'm going to flag it. I'm going to move on. And then when I have extra time, I'm going to come back and I'm going to do another test. I'm going to do test 2 so that I can really see, okay, let me pick new numbers and just kind of see where we're at And then it'll show that B is the correct answer. But when I do multiple tests, it allows me to confirm my suspicions, if that makes sense. Leah, yes, it depends. It actually depends on what test you're taking. The GK math actually allows for about 2.5 to 3 minutes per question. Some tests allow for only 1 minute per question. Some tests allow for a little bit more. If you specifically want to know, my friends out there, if you specifically want to know how many minutes per question you have, feel free to message me or comment, and I will figure it out for you and bring you the answer the following week. But if you want to know, like, hey, on Praxis 5003, how many minutes do I have per question if I were to not have any time left over, or if I were to have 10 minutes left over, I'm happy to do that for you and help you figure that out. All right, let's move on to problem number 3. Let f be a function defined by f of t equals the square root of 4 minus t squared. Which of the following is the domain of f, the set of all real numbers t, so that f of t is a real number? So that f of t is a real number. Okay, so this equation might not look familiar to everybody here. This is definitely a high school 6 through 12, 7 through 12 kind of problem. So let f be a function defined by f of t such that this creates a real number. So if you have no earthly idea what this looks like, then what I suggest that you do is you use your answer choices to figure out which one is correct. So we have t is between -2 and 2, t is bigger than -2, or t is bigger than 0. I'm going to start here because it's the most inclusive, and I'm going to plug in -2 into, no, I'm going to plug in, I'm sorry, I'm not going to plug in -2 because we know that, yes, I am going to plug in -2. I'm sorry. Because by plugging in either -2 or -1, I'm either showing that it's going to be 0 or it's not going to be 0. Because if a negative number produces a real number, then I know C is incorrect. Does that make sense? So the square root of 4 minus t squared. So -2 squared. The square root of 4 minus -2 times -2 is 4. The square root of 0 is 0, which is a real number. So that means that C is not correct because -2 works. Does that make sense? -2 works. It doesn't create an imaginary number. We're not looking for a perfect square. We're looking for not imaginary numbers. We're looking for real numbers, which means we can't end up with no negative square roots. So now I'm going to plug in something that's less than -2 to either confirm that all real numbers is true or to say that that's not going to be the answer. So let's go ahead and plug in -5. The square root of 4 minus t squared is -5 squared. The square root of 4 minus -5 times -5 is positive 25. 4 minus 25 doesn't matter what it is. It's going to be a negative, which means all real numbers is not possible. So now I need to plug in a number that is greater than 2 because it's either between -2 and 2 or it's bigger than 2. So now I'm going to plug in a number that's greater than 2. The square root of 4 minus 7 squared. The square root of 4 minus 49. It doesn't matter what that is. It's going to produce a negative square root. So that is not the correct answer because it cannot go into infinity, which means my restricted domain is A. Now, what does this graph even look like? Now, you don't need to know what this graph looks like necessarily to be able to solve this problem, but what does it look like? Like if your brain is like, I want to know what this graph looks like, what kind of graph does it kind of remind you of? Kind of reminds me of a quadratic a little bit because of the squared. Kind of reminds me of a square root function because of the square root. Could also remind you of a circle too. What is the circle formula? X squared plus y squared equals r squared, right? If we are centered around the origin and not doing any transformations. So now let's set it equal to y, or f of x. Subtract x squared from both sides. Y squared equals negative x squared plus r squared. Square root both sides. Y equals the square root of negative x squared plus r squared. That looks exactly like this problem, doesn't it? Or the square root of r squared minus x squared. So r is 4. And when we square root it, we're cutting that circle in half. So my graph, the radius is 4, centered around the origin because there's no transformations happening. There's no like x minus 3 or anything like that. And it's a half circle centered around the origin. That's pretty cool, huh? Like I always knew what the circle formula was, but when I saw this problem and I started really playing with it, I was like, oh, that's interesting. I never knew that. So now you know. In case you see something like this on your high school exam and you're like, oh, that's that half circle thing. So if you have a square root that has that kind of setup underneath it, now you know. All right, let's move on to the next problem. Valeria, I am so glad that you said that because that's why I love math too. I was literally sitting in my bedroom playing around with this problem and I was like, oh my goodness. Like I can't go out there and tell my husband what I just realized because he's going to be like, seriously, that's not cool at all. But I got so excited. So I just wish I could give you a big hug right now because I wish, listen, Leah, you and me both, I wish I could give you guys a big hug and be like, this is so cool. Okay, moving on. All right. In the triangle below, what is the sum of A and B? In the triangle below, what is the sum of A and B? Yeah, no one gets it. And as like someone who considers herself like a closet math nerd, it's hard for me to be impressed with math. And so when I was impressed by that problem, I got super excited. All right, back to math. What is the sum of A and B? So this problem is 100% like high school 6 through 12, 7 through 12. But there's some vocabulary in here that everybody should know. Sum means answer to an addition problem. And this is a right triangle, right? So we have the answer to an addition problem and we have a right triangle. Okay, that's about as far as the elementary math goes here. But I always like to try to tie something in. So there's your bow on top. All right. I am hoping we're going to get through this hour because my voice is shot. I can already feel it. All right, what is the sum of A and B? Okay, we have the hypotenuse, which is 5. However, we cannot use Pythagorean theorem because we don't have A or B. So I can't do A squared plus B squared equals C squared because I'm missing too many pieces of the puzzle. However, what I notice is they gave me an angle measurement. And as soon as I see an angle measurement, I think of trig functions. So I think of my right off the bat is what I'm thinking. And so when I think of SOHCAHTOA, I'm thinking, okay, which of these trig functions can I use with this angle to figure out one of these missing pieces, A or B? So I can do opposite and hypotenuse, or I can do adjacent and hypotenuse, but I need to include the hypotenuse or I'm going to end up with too many missing variables again. So I'm not going to use tangent. I can use sine or cosine. It doesn't matter which one. One will spit out A and the other will spit out B. So I'm going to use sine just because I like sine. Sine of 20 equals opposite, which is A, over hypotenuse, which is 5. Multiply both sides by 5, and I get 5 sine of 20 equals A. Handy dandy calculator, because that is certainly not something I keep in my brain. Sine of 20 times 5. So A equals 4.564. All right, now we need to find B. Now, you theoretically could do the Pythagorean theorem at this point. However, that's not going to be the most accurate way to solve this because this is not an exact answer. It's a repeating decimal that is an irrational number. Remember that vocabulary from 2 problems ago? I did that on purpose. So this is an irrational number, and I don't like using another separate formula when I have the ability to solve it using a different method. So I'm not going to use Pythagorean theorem here. I could use Pythagorean theorem here, but I'm not going to. I'm going to do cosine of 20 equals adjacent B over hypotenuse. And I'm going to solve so that I can get the most accurate answer because some of these are a little too close for comfort. So now I'm going to do cosine of 20 times 5, and that equals 2.04. So when I add that to 4.564, I get 6.61. The closest answer to that is B. It should say 6.61. That was a complete typo on my end. So this is not like, that's not a 4, that's a 6. It was just a typo. All right, questions about that? Yes, no, maybe so. All right, let's move on to problem number 5. How would you classify the shape below if angle A is 41 degrees and angle B is 98 degrees? The image is not drawn to scale. How would you classify the shape below if angle A is 41 degrees and angle B is 98 degrees? Image is not drawn to scale. Okay. So already I see that I have an angle that is greater than 90 degrees. This problem is for everyone. Everyone needs to be able to classify triangles. Ooh, y'all, this is rough. Okay. So angle A is 41, angle B is 98. Do I need to figure out the other angle? Some would argue yes, some would argue no. 98 tells me immediately that I'm dealing with an obtuse angle. Let's go over some vocabulary. Acute is an angle less than 90 degrees. Obtuse is an angle greater than 90 degrees. And a right triangle or right angle is an angle that equals 90 degrees. An isosceles triangle has two equal sides. A scalene triangle has no equal sides. And this one's not listed here, but I want you to know an equilateral triangle has all equal sides and angles. So you have to figure out what the other angle is to be able to decide if this is isosceles or scalene. So how many degrees are in a triangle? Degrees in a triangle equals 180. So 98 plus 41 equals 139. And 180 minus 139 equals 41. What does that tell us? That right there tells us that we have two equal angles. And when we have two equal angles, we have two equal sides. This side is going to be equal to this side. Image not drawn to scale. So when we have two equal sides, we know it's isosceles. So is it isosceles acute or isosceles obtuse? This is going to be isosceles obtuse because we have one obtuse angle. You can't have more than one obtuse angle because then it would equal more than 180 degrees just with the two angles. So in an obtuse triangle, you can only have one obtuse angle. Does that make sense? All right, let's go ahead and move on to problem number 6. What combination of shapes could you use to create the shape seen below? What combination of shapes could you use to create the shape seen below? All righty, so are we looking at a square and an isosceles triangle, a rectangle and an isosceles triangle, a rectangle and an equilateral triangle, or a square and an equilateral triangle? So we can pretty clearly see that this is our dividing point. So we've got shape number 1 here, and we have shape number 2 here, right? And we never, ever, ever want to assume that what we have is drawn to scale. So we have to use the information given to us. We can immediately see that shape number 1 has a length of 6 and a length of 12, which tells me this is not a square. It's most definitely a rectangle because I don't have 4 equal sides, right? And then I can see that I have a triangle up here. And I'm going to use blue. This side and this side are equal. That's what those little tick marks mean, which means that if this side is 5, this side is 5 also. So what is this side going to equal? That side is going to equal 6, which tells us it's not equilateral, but it is isosceles because I have 2 equal sides and I have a rectangle. So this is absolutely B. Y'all are doing a good job tonight, and I'm loving the interaction. I'm loving that you're trying it. I'm loving that you're not afraid to answer the questions, even if you might get it wrong. Like, That makes me happy. All right, let's move on to problem number 7. Problem number 7 is going to mimic problem number 6. We're just going to actually find the area. What is the area of the composed shape below? What is the area of the composed shape below? All right, so when we're doing area of a funky looking shape, y'all, I don't have a formula for the area of a flat pencil looking shape. We don't have a formula for that. So what you have to do is look for different multiple shapes that we have that we do know the formula for. Like, I know the formula for the area of a rectangle. I know the formula for the area of a triangle. I know the formula for the area of a circle. Like, all of those things are often half circle, circle divided by 2. Like, all of those are formulas that we can use. So in this situation, I'm going to cut this into 2 shapes that I know. I know a rectangle's area equals length times width. And I know a triangle is, and I'm going to use a different color for my triangle. A triangle is area equals 1/2 base times height. So the area of my rectangle is easy. 12 times 6. 12 times 6 is, why do I not have that on the top of my head? I don't know, because I'm tired, y'all. That's why. 72. So area is 72 of the blue shape. Done. Area of the triangle is 1/2 base times height, which equals 1/2. We already talked about how this length is 6. So 6 times height. Do not get mistaken that the height is 5. I always relate it back to like when you have kids or you were a kid and you went to the doctor and they asked you to measure yourself, how tall you were. You stand up straight up against the wall, right? Like your feet aren't out here. They don't measure how long you are with your feet way out here. They measure you standing straight up tall, and that's how we measure triangles too. So what I have to do is I have to drop a height right here. And then I have to figure out, what is this measurement right here? Well, if you're like, I'm really not sure, what I notice is that they gave us a measurement down here that we haven't used yet. They tell us from the very end of the rectangle to the very tip of the triangle is 16. And I know from the tip of the rectangle to the end of the rectangle is 12. This right here, y'all, first grade teachers, second grade teachers, pre-K through 3 people, K through 6 people, this right here is a part-whole diagram. My whole is 16 and part is 12. What is the other part? 16 minus 12 is 4. The height of my triangle is 4. So 1/2 times 24 equals 12. And then I can just do 72 plus 12, which equals 84. Questions on that? Leah, you are good, my sister. You've got this. One thing at a time. One thing at a time. We've got this. Questions? All right. I'm going to skip that one tonight. Yeah, let's do this one. Which of the following shapes would satisfy all of the following constraints? Which of the following shapes would satisfy all of the following constraints? So these kinds of problems, they love on tests. They love to give you some constraints and say, which of the following is this? So it has to be a quadrilateral. It has to have 2 pairs of congruent parallel sides. And it has to have 4 equal sides. This right here is the most constraining of all of my constraints. And so when I look at this, I'm going to look for the shape that has 4 equal sides. Can a parallelogram have 4 equal sides? Yes, but it doesn't have to. A parallelogram can also look like a pushed over rectangle, and so that is not the correct answer. Can a trapezoid have 4 equal sides? It could, but it doesn't have to. That's not what defines a trapezoid. Can a rectangle have 4 equal sides? It can, but it's not what defines a rectangle. But you know what? What defines a rhombus is that 4 equal sides. What separates the rhombus from everything else is 4 equal sides. What separates the rectangle from all of those? Perpendicular adjacent sides or 90-degree angles. 90-degree angles or perpendicular adjacent sides, which just means that the sides that are next to each other, adjacent, are perpendicular, which perpendicular means creates those 90-degree angles. These kinds of problems are extremely vocabulary heavy, so it's important you know your vocabulary because they are so heavy with that vocabulary. All right, let's keep going. A regular, not a hexagon, that's definitely an octagon. A regular octagon can be seen below. What is the measure of angle D? What is the measure of angle D? All right, so the first thing I want us to notice is that the measure of angle D is the exterior angle for this octagon. The measure of angle D is the exterior angle of this shape. It is not the interior angle of the shape. So that's the first thing that we want to notice is it's the exterior angle. That said, what we need to do is figure out, okay, what are we looking at here? Now, this shape is drawn to scale because this is a regular octagon. So I can pretty quickly see that the answer is not going to be C or D because the interior angle is an obtuse angle. The exterior angle is an acute angle. So I can narrow it down to either A or B. Now, how do we figure out the measure of the interior angles of a polygon? By using a formula. And that formula is the sum equals n minus 2 times 180. And that equals the sum of all of these angles, where n is the number of sides. So the number of sides in an octagon is 8. 8 minus 2 is 6 times 180. 8 minus 2 is 6 times 180. This is going to be the sum of all the angles. This formula is going to be super helpful for you to know, for sure. There's few formulas that I'm like, you should know that. You should know that. So 6 times 180 is 1,080. That is the sum of all of the angles on the inside. How do I figure out what just this angle is? Well, I can then divide that by 8 to figure out one angle because all of the angles are going to equal each other. They're all going to have the same measurement. So 1,080 divided by 8 is 135. And 180 minus 135 equals 45. So the answer is B. All righty. I am going to stop there just because I feel like my throat is about to catch on fire. So let me know in the comment box, what do you want to see in the upcoming week? What have we done so far? What have we not done so far? What kinds of problems are you like, that was a good problem and I want to do something like that again? Or you really haven't done a whole lot of X, Y, and Z. Like, could you do a little bit more of that? I have some problems that someone requested on Facebook set up for next week. But if you're studying throughout the week and you're like, man, I really wish Amy would go over that, let me know on Facebook. Find me on Facebook. Tag me in our groups at Amy Sink. If you don't tag me, I probably won't see it. But tag me in a post and let me know, hey, I was working on this problem. Take a picture of it and send it. And I'm happy to include it or something like it in the upcoming weeks. Feel better and take a tablespoon of hot sauce. Fascinating. Never heard of that, but I will definitely be trying that because we are getting over pneumonia in our house. My little one has pneumonia, and I think I am just catching like the sinus cold stuff that has to do with all of that. So I appreciate it. I'm going to turn it back over to Dr. A, and I will see you guys next week. Is next Wednesday Halloween? Or is it next Thursday? I mean, not that it matters. No, it's not Halloween. Next Thursday. Well, it does matter because I'll be trick-or-treating with my little one. Can I do more problems like number 8? Oh, like this one? Yes, absolutely. I will next week. Heavy geometry vocab constraint problem. Okay. And operations and algebra, what specifically would you like in regards to that? Clarify that for me and let me know. Slope. You got it, Leah. Slope. I will stick around and monitor the comments. Otherwise, have a great rest of your week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great. But she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.